Hello, we're back. I'm back. You're back. This is module number 15. This is a discovery demonstration. We all know what this is, right? It's a flask. This is an Erlenmeyer flask. These are the ones that go down like a triangle. The round bottom flasks, those are the Florence flask. But anyway, is there anything in here? Sure, there's air. Does air have weight? Not a lot, but it does. So what I'm going to do, I'm going to take this balloon and put over the top of the flask and I'm going to weigh it. Now this scale, I've made sure it's balanced. There's a little wheel that you can turn, and I'm watching a little needle, and there's a scale here, and when the needle is right in the center, that means it's balanced, it's calibrated. So I'm going to put this over here, and I have some weights here. Let's see, 50 grams, 20 grams, 20 grams, starting to move. Here's 10 grams. It's too much, right? You keeping track? How much we got here? How much we have? We have 50, 20, and 20. We have 90, right? This one, 2 grams. And once that needle gets in the center, I know the number of weights we have here. That's how much the flask and the balloon and the air. That's how much it all weighs. That's pretty balanced. Looks pretty good. So 92? It was 92, right? 92 grams. Okay. That's the weight of the flask, the air, and the balloon. Over here is hot water. What's going to happen when I put this system in the hot water? Think about what you think is going to happen. Let's see what happens. Okay. Now, just turn it so I don't have to hold the hot water there. What's happening? Think about it. What's going on? Some people, some elementary child may say, okay, there's more air in here. Do we have more air? No. What can we do to prove that we have the same amount of air? What do you think? We can weigh it, right? So and we picked up some water, so might be slightly different. Let's see. It's the same. So why did this happen? Can you make an inference? Have the same amount of air, But that air is doing what? Now some people may be saying, well, hot air rises. Well, but there's still air here. We have air throughout this whole system. The air, what's happened to the air molecules? Don't say the molecules are getting bigger. The molecules are the same, but the distance between the molecules are greater. In the hot, being heated up, heating up the air molecules, now they're further apart. So they do what? They take up more space. Think about that. Got a little deflation going on here. Let's get it back up again. Let's get the balloon. Now it's not going to blow up all the way, because when you blow a balloon, you blow on it, right? And you have to put a lot of pressure. So we're not going to get the balloon to blow up all the way. So now we got it back where it was. Ooh, look at this. Ice cold water. What's going to happen when I put it in ice water? Think about it? Well, let's see. Okay. Now, don't do this at home, because this is special glassware. This flask is made out of special glass that you can go from hot to cold. If you did this with a regular bottle, it would break going from hot to cold. So, but look, not only did the balloon deflate, it's almost going down inside the flask. Now it's not going to do it probably because there's too much air in the balloon to begin with. It's almost going in there. Huh. It's still pretty warm around the top. So now what's happening? The air is colder, and now the molecules are closer together. So now the air is more compressed, and something has to take up that space. You're not going to have a vacuum there. So this balloon is going in there, taking up that space. You may say, well, a child may say, a third, fourth grade student may say, oh, look, we have less air. Well, if we weigh it, I don't even have to look. Except for some of the water that we picked up, it's going to weigh the same. This activity teaches the relationship between temperature and the volume of a gas. The higher the temperature, the greater the volume of a gas. The lower the temperature, the less volume of a gas. Okay? And this also, notice I was asking very specific questions. And when you teach, you don't just do the activity and show the activity, you ask questions. And of course, none of you are answering the question because this is being filmed, but still. We're going to have fun now. I'm going to take the balloon off, and I'm going to put the flask in the hot water, which is really hot now, and we're going to put it in there without the balloon. So now, what's happening to that air? The air still is going this way, it's going out, but now it's going out to the room. So I'm going to force as much air out of this as I can, so there's less air than what we started with. Then I'm going to quickly put the balloon back on here, and then we're going to put it in the ice water. And now see if we can get that. Well, we'll see. Let's see what happens to the balloon. Ooh, that's getting hot. That should be enough. I got to act quickly here. Okay, watch carefully. This time it popped in. Well, because there was less air in the flask. So now, when the air compressed because of being cooled, there was a lot of space that the balloon had to take up. And it popped all the way in. Think we can pop it back out? Let's go back to the hot water and see if we can pop it out. Now the balloon is bigger than the neck of the flask, so sometimes it gets stuck in that little thin area, that little skinny area, but whoa, look at that. There we go. So the relationship between temperature and the volume of a gas. I believe I can cut this down. Then I'll cut it off. Okay. See you next time.